Hi, I am Mayank Saxena, Senior Director of Engineering of Data Fabric Solutions at MSL, Samsung. In this talk, we are presenting high-performance object storage, which enables the fast emerging use case and need of high-performing real-time analytics over large-scale object storage, utilizing disaggregated computational storage. High performance object solution, in short, HPOS, and this is the acronym I will be using a lot in this session. This solution, that is HPOS from Samsung, has been mindfully architected with the customer use case in mind and utilizes the emerging concept of S3 select, where data sets of interest, that is specific columns and chunks within them for a particular query, are processed versus the traditional way of transferring the complete data set to CPU for processing. As you can see on the top right, various ML applications needing to serve real-time analytics utilizing S3 now have an additional standard interface of S3 select of HPOS, enabling applications to have data of interest chunked and stored in computational storage, where utilizing our computational SSDs acceleration capability to perform near data processing. Major benefits of HPOS: faster performing queries, higher throughput with lesser network traffic, and lower TCO with reduced CPU usage. This slide shows the normal I/O path and the additional S3 select I/O path which we have implemented. The stack can be seen in three parts. Top, S3 client running in cloud or in a server anywhere. Middle, HPOS software server, which basically uses our DSS object storage. DSS is a disaggregated storage solution by Samsung and is completely open sourced. And I will talk about on that a little bit more towards the end. HPOS software server also consists of target software layer with KV interface. And the third, that is bottom part, is computational SSD, that is smart SSD with accelerated scan function. From the functional flow perspective, on the right, there is a standard get put path for object storage. And on the left is what we have implemented, the standardized KV select to support S3 select in compliance with S3 protocol. KV target software layer, which carries the implementation of KV select, then talks to computational SSD's orchestrator layer issuing SQL query. In simpler term here, target layer sends the select query to all the smart SSDs. In turn, smart SSD then invokes the accelerated scan function and execute the query right where the data is, and then return the results back. Target software layer then aggregates results from all the computational SSDs and send the consolidated result back to the host and then to client. All right, now since we know how the HPOS S3 select implementation was done, let's put this to test against the current standard solutions, like for example, AWS S3, or it can be any object storage supporting S3 select without computational SSD. So as you can see on the slide, on the top, we have a AWS S3 setup. And at the bottom, we have a HPOS S3 setup. On the left, you have a standard client, same client issuing the queries to both the object storage. And on the right side top, you have AWS S3, which is a black box. But on the bottom, we have further broken down the HPOS S3 for visualization for this audience into 4 major parts. One is HPOS server, which we have covered in the previous slide. Then the object storage with accelerator, which is computational SSD, and the S3 select scan function implemented in the accelerator. Now, both the object storage shown here, that is AWS and HPOS, they both are hosting the same data set, sample table shown in the middle. In this case, we are using real customers data set. And as mentioned, same client app issues the query to both the object storage in exact same fashion. That is S3 select query out and S3 select response backend. And the query used, which is a count query in this case, is shown in the middle as well. Now, let's see the results. Now we're going to show you using the live demo setup, technically recorded, but completely customer client app usable solution setup. Before I run the video, let me explain the 3 console screens in front of you. On the right, it is HPOS target node CPU usage. When we will run the query, it will capture the CPU usage. On the left, where we will see the drag race, the top window is for AWS S3 and the bottom window is for HPOS S3. So let's play the video. Well, so as you can see on the top, we have issued the query for, wait, I think video has not started. Oh, there you go. So on the top, you have AWS, where we have issued the query, and on the bottom, we have issued the query to HPOS, and it already came back with the results, as well as the throughput and latency, shown as in the highlighted red box. On the right, we continue to capture the CPU usage. And on the bottom, we are still waiting on AWS to return back. So while we are waiting for AWS to come back, this is the good time for you guys to jot down any questions you might have, and I will be really happy to answer them later on. All right. I think it's going to take a little bit more time on the AWS side. It has completed. Finally, it came back. And as you can see, the results, the query results should be same on both cases. That's important, and they are. But on the AWS side, you have a totally different story in terms of the throughput and latency as highlighted in the square box. And let's analyze these results in the next slide. All right, so here we plotted the numbers we saw in the previous demo video. On the top left, you have throughput, which is the amount of data we are able to process or query within a certain time, same window. And as you can see, in case of HPOS S3, it's 100 times more data we are able to process in the same amount of time. And on the top right, as you can see, the latency of HPOS was far better and 250x lesser than the AWS. And at the bottom, since all the heavy lifting was done by the computational SSDs, CPU was not involved. So you can see the CPU usage is almost negligible on the HPOS software server, which is probably in the range of 0.012. So pretty impressive. It's all right. So we have seen a huge improvement in latency and throughput. That's good. But now also, let's translate how the CPU savings we saw results into real TCO savings for customers. For that, we have done additional measurements. We used server vendors' standard power monitoring framework, which reports whole server's power usage per 5-minute bucket. Used 4 servers in this case to ensure normalization. For example, as you can see, server 3 power consumption in general is higher, that's a higher core machine. And also in each server, we had only one smart SSD to get the granular baseline for one computational SSD base numbers. So we ran same S3 select query, one with smart SSD acceleration, light blue bar, and one with smart SSD, one without smart SSD acceleration, dark blue bar. Without smart SSD acceleration means CPU is processing the query, like in any other object store, for example, AWS S3. And what we have observed consistently is, on an average, there is a 6 watts per hour average power saving using single smart SSD, which amounts to around 2% of total server power usage. Again, this is with one single smart SSD. Now imagine when a server is filled with all the competition SSDs performing parallel query execution, and the amount of cumulative power savings we will get helps reducing the carbon footprint. All right, this is the last slide I have to share the state and intention of complete HPOS, that is high performance object storage solution from Samsung, which we have implemented and intend to mature it further. Most part of it already open sourced, and rest will be soon as well. One of the foundational solution or software layer for HPOS is DSS, as I mentioned during the earlier part of this session. DSS is completely open sourced, as shown in this slide in the GitHub link. And as I mentioned, HPOS plus computational storage specific modules will be part of the open source in future as well. I highly recommend for you guys to go and check out the session on storage for new generation of AI and ML by Somnath Roy to learn about DSS more. And briefly, this open source software, what we have, it already has AI benchmarking framework supporting user preferred training and models to run their own benchmarking, client wrappers supporting framework like PyTorch and TensorFlow, and the whole host and target software stack. All right, this concludes my session. Thank you everyone for watching and participating in this. Looking forward to hear back any questions you might have. Thank you.